Hi there, my name is June and welcome to another video of Learning with Levi. In this video, we'll be going over E1 reactions. If you haven't already, check out the E2 reactions video. We'll link that down below. We've also started doing podcast format for those who'd like to reinforce the concepts on the go. I'll link that podcast link down below, and for those just listening, I highly encourage all of you to check out the YouTube video for the visual aspect. Now, in the previous video, we went over E2 reactions. E1 is the other side of the coin. E1 reactions are named so because they are elimination reactions as well as unimolecular. Now, if we recall that SN1 reactions are also unimolecular and that the rate limiting step depends on the concentration of the substrate. Now, displayed right here is what a general E1 reaction looks like. First step is the carbocation formation. That's just this right here. The leaving group leaves, as you can see in the green arrow, and then it forms a carbocation, which is the rate limiting step. Now, because the base is not part of the rate limiting step, the concentration of the base does not affect the rate. The second step is when a weak base, which is oftentimes going to be the solvent, abstracts the hydrogen, as you can see right here in these green arrows, and then the double bond forms. Now, much like the SN1 reactions, a tertiary carbocation reacts faster than a secondary carbocation, which reacts much faster than a primary carbocation. Now, we can think of E1 reaction much like a mortgage payment. Now, let's say you're living in a house you bought 5 years ago and you still have 25 years left on the mortgage. Your oldest son, who used to help you with the mortgage payment, decides to move to a new state with his family. You're left with a mortgage payment, which happens to be the carbocation in this analogy, and the leaving group is your oldest son. Now, the mortgage payment still needs to be paid, and you attack the debt with more of your money to help erase it. And in the end, you're bonded, and in this case, double bonded to the mortgage payments until it's paid off, or you foreclose. Now, we had mentioned in the E2 video that the E1 reactions always follow Zaitsev's rule. And just to recap, Zaitsev's rule states that the more favored product will be the more substituted one. Now, you might be asking, why is that? Remember that the more substituted carbocation, the better. The more alkyl groups help stabilize the carbocation through hyperconjugation. Now, with this in mind, you will always see the Zaitsev's rule or the Zaitsev's product as the major product in E1 reactions. Now, let's move on to the stereochemistry portion of the E1 reaction for a second. Now, if we recall that the E2 reactions, which require a anti-periplanar geometry for the reaction to occur, that's because the E1 reactions involve the formation of a carbocation, which is flat, no specific geometry is needed for that step. Now, with this in mind, both types of alkenes will be formed, the cis or the trans, and the trans alkenes will be the major product, again due to being more substituted, aka the Zaitsev's product. Now, we had mentioned in the SN1 reactions that because the carbocation is the first step, rearrangement can occur. That too can also happen in E1 reactions. Now, as we know, the first step of an E1 reaction is to form the carbocation. The leaving group leaves, and then we have the carbocation. Now, in this example, we have a secondary carbocation, is this right here, and it's because it's bonded to two alkyl groups, one on the left and one on the right, and it's also bonded to a hydrogen, which is not part of the alkyl groups. Now, step 2 is the hydride shift. And now I've highlighted all the hydrogens in red. Now you can see the ones those will shift to help form the more stable carbocation. And as you can see, the carbocation goes from a secondary on the left, and as we shift the methyl or the hydride, the carbocation goes to a tertiary carbocation, which we said before is a more stable one. And now the last step is the base to abstract the hydrogen, the beta hydrogen. And so on top, we have the base abstracting the beta hydrogen to the right, which forms the tetra-substituted alkene. And on the bottom, we have the base abstracting the beta hydrogen to the left, which forms a tri-substituted alkene. Now, again, according to Zaitsev's rule, the top product would be the major product. Now, this concludes our E1 reaction video. Hit that like button, subscribe button, help support the channel, share it with your friends who need help with organic chemistry. In the next video, we'll be comparing E1 and E2 reactions. I'll be putting up more videos, so comment down below what you'd like to see. Social media links are down below, and as always, remember, you got it, yo.